Okay, keeping with the football theme, this one's about the best player in the world at the moment, a guy named Yves Bissouma, plays for Brighton, of course. And currently, Real Madrid are trying to buy him, and the price tag seems to be about $40 million. Okay, so let's imagine that actually happens, and Real Madrid buy Yves Bissouma, and they pay Brighton Hove Albion $40 million. And what Brighton do is they invest that money in a bank account for 3 years, earning 5% interest. Now, I've explained what interest is many times, okay? It's basically the cost of borrowing money. So if you put money in a bank, effectively what is happening is you are lending money to the bank. You're giving your money to the bank. They're borrowing it from you. So they have to pay you interest. You have to pay to borrow somebody's money, okay? So the bank will have to pay Brighton and Hove Albion 5% of their money every single year for 3 years. Now there's two types of interest. There's simple interest and there's compound interest. Okay? We'll go through each one. The simple interest is called simple interest because it's simple, it's easy to calculate. Okay? So basically if we say we've got 40 million, and what we do is each year we earn 5% of interest. So that's 0.05 is the correct multiplier. And we're simply getting that for 3 years. That will tell me what the simple interest is. Okay? So put that in your calculator. 40 million times 0.05 is 2 million, so that's how much I get per year. Times that by 3 years, then we are going to earn, $6 million in interest in total over the 3 years. So that is the amount of interest. Now, how much money will they have in the bank after 3 years if the interest is simple? Well, remember, you don't lose the principal. Remember, this is called the principal. It's the amount of money you start with. You don't lose that. It's going nowhere, okay? So you keep that, plus you get the interest. So the total amount is just equal to your 40 million plus the 6 million you earned in interest. So you now have 46 million. Okay, so putting those into formulas. Simple interest equals the principal, okay, times the correct multiplier for the rate of interest, times the number of times you get paid that interest. So this would be one of the rare occasions where old value times multiply equals new value is not appropriate, okay? So that's the formula. So remember, principal times the rate of interest times the number of times you get paid that interest, okay? You need to write that down, you need to know it, okay? So then the total amount will be your principal plus the interest that you earned, okay? Principal plus principal times rate times number of times you get paid, okay? So hopefully that makes sense. So you know, in this one, it's easy to know the amount of interest earned first, and then you work out the total amount that you have. Now, with compound interest, it's the other way around. What you work out first is the total amount, and from that, you can work out the interest. So let me explain that. Okay, now, with compound interest, is a different type of interest, because what should happen is after the first year, you get paid some interest. Well, then you should also earn interest on the interest, as well as the interest on the principal, okay? So let's just have a look at what that means in practice. So how much money will they have in total after 3 years if the interest is compound interest? So what we do is we get the principal. And what we're going to do is we're going to work out how much money they would have at the end of the first year. So we've got 100%, and we're going to add 5%. It's 105%, which is 1.05. Okay, this is how much money you would have after year 1. Well, after year 2, it would, because you're now earning interest on the interest, you would earn interest on all of this amount. So you would take this amount and you would times it by 1.05 again. Let's just use some different brackets. So that is now how much money you would have after year 2. And the same thing would then happen after year 3. You would take the amount of money you had after year 2, which is in blue brackets, and multiply it by 1.05 again. Okay? And that would tell me how much money I would have at the end of 3 years. Now, a quick way of doing that is saying the total amount you'll have after 3 years is equal to 40 million times 1.05 times 1.05 times 1.05, which is 1.05 cubed. Okay, to the power of 3. So we're going to put that in a calculator. Just do that. 0.05 to the power of 3. So we're going to end up with 46,305,000. Okay, that's presumably rounded a little bit, but that's the amount of money that we'd be expected to have. So it's only now that answers part C. Only now can you answer part D, which is say how much interest did you earn? Well, the compound interest you earn must be the amount you have now minus what you had in the first place, the principal. So this time you earned $6,305,000 in interest. Okay, so you work the other way. You find the total amount first, and then you find out the compound interest. Okay? So, compound interest is better. We earned more money. It was only 6 million with simple interest, but it was, we earned an extra £305,000 by having compound interest instead. Now, let's just make that into formulas. The total amount in compound interest is equal to your principal times the rate of interest plus 1, okay, to the power of the number of times you get paid interest. Okay? Now, I hope that makes sense. Now, this actually is that formula. Old value times multiplier equals new value. If we think about it, the old value is the principal, okay? And the multiplier is the correct multiplier to the power of the number of years. So I could just perhaps adapt it a little bit to old value times the multiplier to the power of the number of times you get paid is equal to the new value. And that formula is true for all types of circumstances where there's repeated percentage change. So you're not just increasing something by a percent one time, but maybe 2, 3, 4, 5 times. However many times you're doing it, that is what that number n needs to be. So it is actually the same formula. Okay? Here's some sort of relatively straightforward questions. Let's just do them together first. Julian invests £7,500 in an account paying 2.8% simple interest per annum. How much does he have in the account after 3 years? We've got to work out the interest first. It'd be 7,500 principal. Actually, I'm being lazy. Let's write down the formula. Simple interest is equal to principal times rate times number of times you get paid. Principal is 7,500 times the rate, which is 2.8%, which is 0.028 times 3, the number of years. Okay, so put that in your calculator. 7,500 times 0.028 times 3 equals 630, which is actually the answer to part 2. The answer to part 1 is the total amount it'll have is 7,500 plus the interest. So that's going to be what? 8,130 pounds. Okay? But Matt invests with compound interest. So how much does he have in the account after 3 years? Old value times multiplier to the power of n equals new value. So the principal was 7,500 times the correct multiplier. This time is 1 plus 0.028. So that's 1.028 to the power of 3, because we got paid it 3 times. 7,500 times 1.028 to the power of 3 equals 8147.80, 2 decimal places, because it's money. Okay, so how much interest for part 2? We'll just simply take away 7,500, take away the principal, and you've earned 647.80 in interest. Okay. A car is worth £17,000 when new. It depreciates at 11% per year. Now, although this is not compound interest, it's very, very similar. It's talking about changing something by a certain percent repeatedly, like I mentioned earlier in the video. So we can use that formula, old value times multiplier to the power of n is equal to the new value. So the car is worth £17,000 and it depreciates at 11% per year. So depreciate means the price goes down. So that would be 100% minus 11% equals 89%, which is 0.89 per year. And we're doing that 5 times. Okay, so we're going to do 1,700 times 0.89 to the power of 5. So the answer is now 949.90 pounds after 5 years. How much value did it lose? Well, it's going to have lost 17,000 minus what it's now worth. Okay, so 17,000 minus the answer. It's lost 16,050.71 to 2 decimal places. Okay, hope that makes sense. There's going to be one more video, which is some practice around